So my name is Daniel Flynn. I'll still give it a couple of moments for some stragglers. So the title of this talk for this segment, I think the way it's structured is about 10 to 15 minutes presentation from my side, and then the rest of the time is opened up to Q&A from your side. So I'm super happy to take lots of questions. The more detailed questions, the better, in my opinion. So this is fine. Basically, as I'll show you in this, I work with a company called Bearcover. So Bearcover GmbH, we're a startup based here in Berlin. We're focused on deploying robots to nursing homes at nighttime. Our particular focus, I won't give away just yet, but it's part of the presentation. And I'm basically going to take you guys through how we built a business that we think can be replicable for other robotics companies in our approach. And maybe if anybody is ever thinking about entering the hardware space, I have 3 tricks to help. A lot of them help just startups generally, but also specific to hardware to kind of, I would say, focus on how we keep our iteration cycles as short as possible to make sure that we're doing the correct thing. So, without any further ado, I will begin. So, I'm Daniel Flynn, obviously CEO and founder of Bearcover. We're focused on making nighttime manageable in nursing homes. I'm one of 3 on the founding team, so just to give you a little bit of background. Ben is our Chief Robotics Officer. He joins us from Accenture's innovation team and has a background mostly in computer engineering and algorithmic design. Fernando was former Bosch as a deep learning engineer, working mostly in autonomous vehicles and vision systems, so combining hardware and software for autonomous vehicles and concepts at Bosch. He's our Chief Technology Officer. And then I have a background that's mostly in enterprise SaaS, that's software as a service, working across business development and product as functions. We've actually worked together for over 5 years, so I actually know Ben much, much longer. And many years ago, we played in a rock band together in our school days. But we've been teammates for over 5 years, a strong working relationship, and we moved to Berlin last year to make it official and begin a company. Yeah, so these are kind of my quick and dirty robot company hacks. Yeah, so if you were to ask me now what I know from a year at this, what I would focus on, or what any startup that's working in hardware or robotics specifically should focus on, this would be it. So first and foremost, address a real problem. And this goes for any business you're building. You'll often hear people in the startup space talk about problem and solution. So like, what is the real need, the pain point, the customer issue that you are addressing? And then what does your solution do to solve that in a novel way? Perhaps like obvious, but it should be repeated again in number 2. Unit economics matter immediately in hardware. So in software, you can sort of build these businesses that, yeah, okay, I'm losing money, but there's a break-even point here later on, and I can basically pull to profitable from unprofitable at any moment, yeah? So then you can kind of prioritize growth. But in hardware, I think when you sketch out the idea, yes, you can make discounts for manufacturing and all that sort of stuff, but it's much harder to get investment if you can't show a path to profitability immediately. So in many of our iterations of design or product or even approaching markets, one thing that we like to pay attention to is kind of what is your bill of materials, and then what reasonable margins can you make on top of that, and you know right away whether or not your business even holds water. And then number 3 is perhaps the most counterintuitive thing we were ever told. So if you want to be a successful hardware company, do not build your own hardware. Yeah, this sounds crazy, but if you actually think about it, and I think I'll make a good case for it later on, this, I think, was the most valuable advice we got in our entire time doing what we do. So, true to my word, the first thing that we're going to talk about is problem. So the problem that Bearcover solves specifically is that nursing homes have limited staff at nighttime, in Germany especially, and all of those staff have to check, change, and turn residents. So in Germany, let's talk about the care system. So you have minimum staff operating in ratios of about 30 or 50 residents to 1 person at nighttime. That means it's not uncommon for a nursing home of, let's say, 100 people split across 3 or 4 floors to be cared for by no more than 2 people at nighttime. This means 1 registered nurse and 1 care assistant. So each of these members of staff has to physically enter the room in order to tell whether or not someone is okay, so to perform their mandatory check. In Germany, I think the laws are about twice per night. in other regions, like Ireland, for example, people will be checked, maybe every 30 minutes to 60 minutes routinely throughout the night. And this is due to kind of greater staff numbers and kind of dynamics of the care. But all of this is to say that when your staff are busy at nighttime, say somebody has an accident and you need to be attended to, or there's just multiple things going on at once, busy staff mean reduced checks. So maybe you don't get to check the rooms as frequently, and the reduced number of checks lead to more accidents. Like on a personal anecdote for us in this idea is the idea that one of our nursing home clients said to us, I have this problem where occasionally, like every so often, one of our residents will fall or leave their room and fall, and then we will find them on the ground 3 hours later. And I have to explain that to a very angry family. And we said, okay, this is a really interesting problem that you guys have. And basically we landed in this place. Yeah, so corridor robots that support staff checks by identifying who needs you next. So the idea is that if you could automate some of the checking behavior of staff at nighttime, you would be able to then tell the staff where they should be. So you know that somebody is out of bed, you know that someone has fallen, and the staff can go immediately and take care of that person. So the way that we do this is we combine corridor robots. So these are robots that inspect corridors visually. So we use a combination of depth sensing, which you can see here from an Intel RealSense. So this is a depth camera, special camera that gets depth information. And we use a LiDAR. So this is just a 2D planar LiDAR. And then this allows us to navigate inside in the nursing home. And then we can I suppose this is the hallmark of our approach, which is a little bit different to everybody else, is that we decided that the real value was being able to see into the room. And in order to see into the room, ideally, we wanted to be able to check the rooms without entering. So we use a combination of ultra-wideband radar, which allows us to basically see through doors and walls. And we were able to then check on the staff or check on the residents without disturbing the residents, without entering the rooms, without placing devices in the rooms. And then we can relay these alerts directly to staff devices, directly to smartphones. So UWB radar, ultra-wideband radar, allows us to see through closed doors. This means that our devices, if you imagine, are active on a corridor, are able to check presence, first of all. Is somebody in the room or are they not in the room? This is important to know because people can wonder. Is somebody moving? So if it's 2 a.m. and somebody's moving around their room, it's probably a good reason for the nurse or the carer to just check to see if they're okay. This is standard practice. And then out of bed detection or fall detection. Are they on the floor? Are they out of bed? Should they be out of bed? Certain residents might be a fall risk. And actually any movement outside of bed is a significant risk and should be dealt with right away. So then the key idea here is we can do all of this without disturbing residents. So without entering residents' rooms and potentially waking them up, without putting sensors in the environment that they might find invasive or they may tamper with or that need to be changed or managed by staff. And then your staff can know who's up, who's moving around, and can prioritize a physical check of the residents that need their attention. So we basically take nighttime care and turn it into a logistics planning problem. So like demand forecasting for Uber. So we can tell you, here's a snapshot of what our app looks like. So it works on multiple devices. It's cross-platform designed. Carers can set priority rooms. So if somebody is high risk or needs special attention because they're sick, and then they basically just get alerts notifying them of the area or the region or the room where the event has taken place with some details of the event, and then they can click to pick it up and deal with the event. So that's very quickly my address a real problem. So it's very important if you're building a robotics company to kind of tether your entire business to something that is a very specific customer need. The logic for this is that if you identify a real problem for somebody, they will accept your not perfect solution. That they feel the pain so intensely that they won't mind that your robot isn't perfect, or it doesn't have all of the fancy lights or the beautiful plastic on it, but it really solves something so painful for them that they are willing to accept a suboptimal solution in your eyes that's actually the most amazing solution for them just because it works. So then the second point that I'd like to touch on is unit economics matter immediately. So I think Marvin mentioned it in the intro. So when we first arrived in Berlin last year, we had the idea of designing robots for let's say my age groups, someone like you or many of the people in this audience, So the idea was you could build a device for the home using existing robotic technologies that would support people in their home. So we basically iterated through a couple of designs in our home, because the year homes is 2020. We realized that arms are too expensive, that the technology is still too far out to be basically valuable for the consumer. So for an average consumer, the devices would have to be so expensive that they wouldn't be worth it, and they basically wouldn't perform the way we would need. So we said, okay, no. So then we iterated into the ambient assisted living space. So what's interesting about that is we basically looked at the market we were in, the technologies we had, and we said, there are, if you're going to deliver robots in the home for people, it has to address a concrete need for that user base. There are two groups of people with a concrete need in the home: older people, and then let's say maybe disabled people. And as far as we're aware, the market for disabled people is not getting larger every year. So as a startup, we decided, okay, the graying Europe was a better market to approach. There was a lot of good that could be done helping people live longer at home, and we entered this market, and we were iterating through devices in this. And then ultimately our partners, so this is kind of how we came into the older space, the elder tech space, together with nursing homes. And ultimately they pushed us, or pulled us, whatever way you would say, into what we do now, which is specifically for nursing homes. And maybe I'll just talk a little bit about the price breakdown, because we use what's called a RAS model, so robotics as a service. We borrow this from manufacturing. So the traditional hardware model is like you sell a product with margins built in. You pay for it once, you get the product. That's normally how hardware operates. Unfortunately, fortunately or unfortunately, whatever way you view it, hardware has become more complicated, and hardware also has a large software component. And in order to provide a long-term service connected to a hardware device, you need to be charging, let's say, a subscription service in order to maintain the service and continue to develop and build. So if we look back at these, the homes would have to have been a subscription service to work, but we identified that the tech would price it outside of the consumer. Ambient assisted living, we were also looking at a subscription pricing, although we're playing with some margin stuff. But nursing homes, very naturally, because you're no longer going B2C, so direct to consumer, in the ambient assisted at home case. As soon as you look at nursing homes, you're in the B2B context, where a recurring revenue model or a RAS model makes much more sense. It's easy for your clients to get used to. They're used to service models. So we charge about 300, well, we're charging slightly less for the pilots, but we're moving to a price of about 399 euros per month per device plus VAT. Our hardware costs are about 2,000 euro. That's not including all of the costs of engineering and staff and all of these sorts of things. But the payback on devices is about 5 months. And then our customers contract for about 12 to 24 months, which gives us kind of a nice margin on our contracts. And then we can also provide additional data infrastructure. So if a nursing home needs 5G, or well, not 5G, if they need 4G or 3G because they don't have suitable Wi-Fi infrastructure, we can provide all of this through our service as well. So this is kind of, I would say, a healthy snapshot of what a hardware company should look like if they're trying to do RAS. You want a payback that is reasonably short. So let's say 4 to 6 months on your device, depending on the price point. And the reason for this is that I wanted to highlight this in this talk is that if you are sketching out a robotics idea on paper, and before you even go build it, you should know if your financial models make sense, because it's very easy for them to completely not make sense so early, and it becomes glaringly obvious. And if you have that information, it might save you a lot of pain and heartache going down a rabbit hole before realizing that it's basically untenable for you. So we can talk a little bit about the market. This is maybe not so interesting for you guys, but we would forecast that the average customer value is about 20,000 euros per home or above, depending on the market that you're in. It's nice, we're the only people in this space, so this is kind of the way that we think of a market, especially a market that doesn't exist. So just 5% of the German market would be about 14 million euros recurring, which is enough for a startup of our size, growing in the 3 largest European markets. And then honestly, who knows how big the total addressable market is? It depends on your geographical dispersion. But once we had kind of figured out unit economics and reviewed this, then we knew that, okay, there could be a business here. We just had to pursue it and then figure out the products that would place that business. So then, true to form, I come to my last point, which is you don't need to build your own hardware. This is I leave the best to last. This is the super secret robot tip. So my tip to anyone who would like to build a robotics company is very simply, don't build, assemble. So probably all of you here are familiar with scooter companies that famously burned money. But we actually took this as a huge inspiration in the way that we thought about our business. So off-the-shelf scooters were used. So basically, these scooters like Bird and Lime and that found suppliers in China that were already making scooters. They stuck some decals on them. They added a lock. They created an app, and they had a GPS tracker, and they basically deployed them in cities. So what this meant is that products had short lives. I think I read in the first generation of scooters that the average scooter lived something like 30 days, but it had to run for 90 days to pay back the money. So these guys were setting investor money on fire. But the huge advantage they had was that it could prove that the market existed instantly. So I think there is no doubt at the moment that micromobility is a very interesting market. And whether or not it will ever be long-term profitable is another question. But there was definitely a demand from a public space, from a city space for these sort of products. And they were able to reduce the time to scale. So if you think of traditional lead times for manufacturing your own hardware, you're talking probably 12 to 18 months, depending on where you do it. So they were able to basically explode in multiple American cities and across Europe using, let's say, a quicker, dirtier version and basically work on dominating the markets. So if you look at our prototype shots, so I'm just walking you through some of the samples we saw earlier, you see the first one on the left is built in-house. So we basically bought components and built it in-house to test our initial ideas. Okay, then we decided that we weren't happy with the finish. So in order to present our product as a more finished product that could immediately be sold to consumers, we decided to take a retrofit approach, which is what you see here in the center, where we basically buy in a robot from another country that we like the specs of, we like the price point of. We gut the insides and we re-CE certify the robots ourselves. So we do the engineering certification, and we basically end up with a product that looks totally finished, totally new. And we can sell right away. So this is kind of our quick and dirty attempt. And then where we are now. So the one on the right is a functional prototype. We're actually in the process of designing our next version. It should be finished in about 2 weeks. But this looks, let's say, more handmade than the middle one. But actually, it's basically the same concept. So here we use a Kabuki base. We're using a robot base that is freely available with an open commercial license. That meant we didn't have to develop any of the wheels or odometry or motor drivers, any of this. That all came as standard. We add our own battery. We add our own cameras and sensors. We build an internal housing and we stick a case on it, which is super easy because we use mostly off-the-shelf components. So, these are kind of my 3 takeaways on this final part here of don't build, assemble. So find a platform that you can build on top of. There's a lot of great robots companies, a lot of great robots that are already out that you can add your sensor suites to. Don't go reinventing the wheel. Try and use what's out there to prove yourself as quickly as possible. Use standard parts from reputable suppliers. So supply chain is always an issue, especially in the West, bringing in things from China. So we use mostly large suppliers. So Intel, NVIDIA, they have good data, they have reliable parts, and this is always good. And then understand that as a hardware company, speed is your moat. So moat meaning your defensible position. So in all companies, speed is super important. But if you can be quick in hardware to kind of de-risk your business proposition to show value to the customers, then that speed is massively important, because other companies have to not only figure out how to enter the market that you're in, but also how to build hardware at a clip that is incredibly fast. And that is not something that is easy to do if your organization is not set up to rapidly build and iterate on hardware and put it into customers' hands. So I'm going to close now and open up to questions from you guys. I'd love to hear anything that you have to say. I'm open to all questions about our process. This was quite a flyby, but just on a closing note, we are always looking for talented engineers in the following areas of robotics or digital signal processing. Specifically, we're really into electronics and radar development. So if you know somebody that's interested in the space, or maybe even if they work in care, we're always happy to talk. We love talking to people that are passionate about the same things we are. And with all that said, thank you very much. I'll open up the floor to questions.